Hi there, this is Callie, here to tell you about Virtel Web Access. How secure is it? Let's start by reviewing the design principles that serve as a foundation to our web access security. We firmly believe that Virtel's simple centralized infrastructure, which relies on nothing but standard web technology outside the host, is easier to support and protect than the decentralized infrastructure of client-based TN3270 emulators. We rely on nothing but standard web technology outside the host, that is, end-to-end encrypted HTTPS connections as opposed to TN3270 connections, and plugin-free web browsers as 3270 terminal emulation clients, as opposed to Java client applets or plugins. We keep control of access to host assets on the host where it belongs, whereas TN3270 emulators rely on distributed Java client applets or plugins, which results in distributed security exposures, and the host losing control of access to its own assets. We also believe that with web-originated accesses, user authentication has become very critical. Are you really who you say you are? Single-factor authentication, such as your RACF user ID and password, is no longer sufficient. Multi-factor authentication, typically combined with SSO, is becoming a must. We believe in leveraging, whenever possible, the security investments made by industry giants. For example, we leverage IBM's ZOS Statement of Integrity by keeping as much of our web access solution as possible inside the ZOS system, where it gets the best possible protection. We also leverage IBM's ATTLS or ICSF for the SSL encryption of HTTPS connections. By relying on plugin-free web browsers instead of applets and plugins, we leverage the huge investments that Google, Microsoft, Apple, and Mozilla are making to improve the security of their products. And by positioning Virtel as an integration component between host applications, host security systems, end users, SSO, and multi-factor authentication, we leverage the creative solutions that come from the very active SSO and multi-factor authentication marketplace. We believe that ultra-thin translates directly into ultra-secure, and that the future of 3270 terminal emulation is in virtual device infrastructure and cloud technologies. From a security point of view, ideally, 3270 terminal emulation clients should only carry the OS, a plugin-free web browser, and whitelisted applications. Desktop applications should be provided as cloud services. 3270 applications should be accessed via the client's plugin-free web browser. We understand that not every organization is ready to go that far in streamlining their client workstations and embracing the VDI trend, but it is feasible, and we will later showcase a recent project where one of our customers successfully replaced their Windows PC workstations with ultra-thin Chrome devices that access both desktop and 3270 applications via the plugin-free Chrome browser. Those are the key tenets of our approach to web access security. Throughout this presentation, we will try to highlight how Virtel Web Access adheres to those tenets. When it comes to security, the strength of Virtel results directly from its host-centric thin client architecture. Virtel relies on host-running middleware, end-to-end HTTPS connections, and plugin-free web browsers, to which Virtel serves standard HTML JavaScript web pages. As for the internet connection, Virtel relies on straight end-to-end HTTPS connections. Those connections are SSL encrypted with ATTLS or ICSF, which, being IBM products, are always compliant with the latest FIPS level, today 140.02. Although Virtel can coexist with a VPN, it doesn't need a VPN to encrypt the data exchanged with terminal emulation users. In fact, some of our customers have simply dropped their VPN. Although these identifiers are infrastructure components, primarily used to manage the session and exchanges, they provide an embedded security feature because they allow detecting and rejecting man-in-the-middle attacks. If a message comes back with an incorrect exchange identifier, Virtel immediately ends the session. Let's talk about 3270 field attributes. As you know, 3270 applications assign one of the following attributes to each screen field. A hidden field shouldn't be displayed to anyone. A protected field can be displayed but not updated. an unprotected field can be displayed and updated. Virtel, which runs inside the host firewall, protected from web attacks, strictly enforces those field attributes. It does not send hidden fields outside the host, and it checks if protected fields have been changed upon return to the host. If so, Virtel immediately ends the session. Now onto custom data filtering. Similar concept as that of the 3270 field attributes we just discussed, but with data filters custom defined by the administrator or security auditor. Administrators can use custom developed Virtel scenarios and templates to filter the outgoing and incoming data flows. For example, outgoing data fields can be hidden, masked, or encrypted. Incoming data fields can be protected from update. This data filtering can be based on user credentials and authorization levels. It takes place on the host, behind the protection of the host firewall. Virtel supports both RACF, ACF2, or Top Secret for user authentication and authorization. Unlike TN3270 emulators, Virtel memorizes the user's authentication and authorization in the form of an application selection menu presented to the user after a successful logon. When an application crashes, users are sent back to their application selection menus. The Virtel administrator can define a fallback strategy when a transaction crashes, or by default, send the users back to their application selection menus. The bottom line is that Virtel users are never allowed to roam free inside the host after an application or transaction crash. Here is the application selection menu that Virtel serves to a user after a successful logon. It reflects the user's authorization level as identified at logon by RACF, ACF2, or Top Secret. The same exact menu is served again to the user after an application or transaction crash. It prevents the user from roaming free after an application or transaction crash. Now let's discuss Web Access Audit Trail. Virtel enables administrators to define the Web Access Audit Trail that they want to save. For example, no tracking when retrieving an image, but tracking when using a VTAM relay. This data can be used to feed a non-repudiation process. It can be stored in a VSAM file and/or SMF, by default SMF record 223. The main strength of Virtel when it comes to security is that it doesn't rely on Java client applets or plugins. With Virtel, the web browser is the client. For each 3270 screen, Virtel generates and serves a new and uncompromised web page, which is rendered inside the web browser's sandbox. Web browser sandboxes are a much safer environment than the Java client applets or plugins used by TN3270 emulators. And web browsers are getting safer all the time, thanks to the constant security investments of their publishers, Google, Microsoft, Apple, and Mozilla, for whom security is a growing differentiator in their competition for market dominance. With Virtel, the security of host assets doesn't rely on thousands of distributed Java client applets and plugins. Now onto macros. Macros are user-developed productivity improvement tools, essentially application extensions, that, because of their business value, should be treated as a business asset and managed by the IT department. But they are not. Instead, they are developed, owned, and managed by end users and stored on the client devices used to access the 3270 applications. They are not inventoried. They are not audited for security, when in fact they can create serious security exposure for the host assets. We've seen TN3270 macros with unencrypted user IDs and passwords and spreadsheets used to activate thousands of transactions at once. Those are dangerous macros that could be used to compromise the host assets. There is little to no sharing between macro developers and lots of duplication. It's a big mess. With Virtel Web Access, organizations can continue to allow users to develop, manage, and store any macro they want on their own workstations, if that is what they really want to do. But Virtel Web Access also enables the administrator to force all user-defined macros to be stored on the host, safe and secure behind the host firewall, where they can be inventoried, audited for security issues, and shared, or not, between users. Administrators can eliminate the duplication and organize the sharing. IT programmers can participate in the development of general-purpose macros. Auditors can ensure that the macros do not cause unwanted security exposures. This productivity tool, application extension, and business asset is back under the control and ownership of the business and its IT department. What about disconnected clients? Virtel Web Access doesn't leave anything that could expose the host assets while the clients are disconnected from the host but still connected to the internet. No host data and no client applet or plugin. There is no exposure for the host if the client is lost or stolen. Let's review the shockingly novel VDI project of our customer Fraken. With 58,000 vehicles in 15 countries, Fraken manages one of the largest European commercial vehicles fleet. In 2016, Fraken decided to replace the 1,500 Windows PC workstations used to access their mainframe applications with ultra-thin Chrome devices from which all applications are accessed in the cloud. This is what Fraken's new 3270 client workstations look like. Chrome boxes in all conference rooms, Chrome bases for the office staff, Chrome books and Android phones for the mobile and sales staff. Internet access is provided via Wi-Fi and broadband HTTPS connections. Only the Chrome OS and browser and 2 authorized plugins are installed on those devices. Software and antivirus updates are managed centrally and automatically deployed to all devices. All applications and data are accessed as cloud services through the Chrome browser. This includes video conferencing and training tutorials, Google and Microsoft desktop applications and cloud storage, and even CICS and TSO applications are accessed as cloud services with Virtel Web Access. Although this enterprise-wide virtual device infrastructure initiative was initially aimed at reducing costs, and it did, drastically, it resulted in the design of an ultra-thin and ultra-secure client workstation, one with greatly reduced and simplified support requirements, and with unparalleled mobility and flexibility. What Fraken did fits perfectly within the scope of this presentation because it embodies the key principles that have been used to design Virtel, its architecture, and its security features. You could say that Fraken has redefined the future of the 3270 client workstation, or that they've reinvented the dumb terminal in the age of the internet. You decide. Once the path from client device to host application has been firmly secured, the last security requirement is user authentication. Are users really who they say they are? User authentication has become more complicated and more critical with web access. Single-factor authentication based on RACF user ID and password is no longer sufficient. Multi-factor authentication, typically associated with SSO, is highly recommended. It typically includes a combination of something you know, something you have, and something you are. Multi-factor authentication typically combines modern authentication technologies such as those listed below. I'm sure that you recognize them. So, what's the role of Virtel Web Access with multi-factor authentication? Virtel can coexist and integrate with any IP security technology, including SSO and proxy servers. Custom-developed Virtel scenarios integrate the SSO, multi-factor authentication, host applications, RACF, and end user as illustrated in the next slide. This diagram illustrates how Virtel integrates the SSO, RACF, host applications, and end user into a comprehensive and seamless multi-factor user authentication and web access system. First, the end user requests access to some host data or screen via an SSO system. Next, the SSO gets an authentication token, for example, SAML, from a multi-factor authentication service. Next, Virtel receives the authorized request from the SSO server, itself authenticated by its IP address and server certificate. Next, Virtel gets a pass ticket from RACF for one-time access to the requested host resource. Next, Virtel uses the pass ticket to get the requested screen or data from the host application. Finally, Virtel sends the requested screen or data directly back to the end user. This is pretty much how most such integrations work. One of the strengths of a system like that is that it doesn't move around any user ID or password. Thank you for watching this video. I hope that you now understand how secure Virtel Web Access is. If you want to know more about Virtel Web Access or other Virtel products, please check our video library. Keep your mainframe front and center with Virtel.